DataStax is the company behind the massively scalable, highly available, cloud-native NoSQL data platform built on Apache Cassandra. DataStax gives users and enterprises the freedom to run data in any cloud at global scale with zero downtime and zero lock-in.
Hey everyone, another day with the new stack, another podcast today. We are with DataStax, and DataStax is one of the sponsors of our new ebook on Kubernetes, the second edition. And joining us is Catherine Erickson, part of the strategy and self-service team at DataStax. Hello, Catherine.
Hi, Alex.
And Patrick McFadden, Chief Evangelist for Apache Cassandra and Vice President of Developer Relations. Hey, Patrick.
How you doing, Alex? Thanks for having us.
I'm really excited to talk with you about Cassandra, about DataStax, about the new operator that you've developed, about Kubernetes overall, a customer journey. I think we'll have a lot to cover in our next 30 to 40 minutes. What I'm really interested in overall, though, is this time we're in really speaks to scaling out. I think it really speaks to how we're thinking about scaled out architectures. And there's an acceleration that we're seeing in the evolution of scaled out architectures. And what DataStax has provided is really the guide, so to speak, for Cassandra and allowing customers who are using Cassandra to think about how they can use data in a much different way across these distributed architectures. And Kubernetes really is the core these days for thinking about distributed architectures and how you use distributed architectures. So let's start with talking about the evolution of scale-out architectures over the last few decades. You know, how do we get to where we are today? What is your reflection about where we are today? Thinking back to, Patrick, perhaps early in your career when you were building out the first forms of scale-out architectures, and what were you dealing with at the time? And, you know, how has that changed? How do you see that change across, you know, the technology landscape?
Yeah. So, I did go from, I was involved in that first .com mess in the late 90s and, you know, when we had tens of users, but it was really, I think the real growth of what happened with internet applications happened in that 2000 to 2010, where that's when you saw the big companies like Google, Facebook, Twitter start to kind of emerge, and they all were trying to solve problems at every layer of the infrastructure. But that's when we saw things like NoSQL databases pop out. If you remember back then, it was just this amazing explosion. I mean, there was like things like Tokyo Cabinet and React, and Cassandra came out during that time. Mongo came out during that time. I mean, it's just all those databases that grew from that. Hey, we have a scaled data problem, and this single relational database is not solving it. And I think that was the first time we really had to solve scale problems and use distributed technology to make it work. But as things progressed and evolved, you know, the application tier is what was addressed next. And we went through a lot of iterations there. DevOps was all geared around that. Like, we learned a lot about Chef and Ansible and Puppet and things like that. But eventually, I think that's where we saw that evolve into what is now Kubernetes. And Kubernetes has done a really good job of, okay, we need to make scale architectures in a distributed nature on our application tier. But, you know, what's happened meanwhile with databases is that databases were a solved problem along that way. And so here we are in 2020, and I think this is a great opportunity. We're starting to see these things come together.
So you're starting to see them come together, and we saw MongoDB in those early days. We saw the emergence of these need for scale-out architectures. We also saw the evolution of APIs and how the REST-based API became so important. And now we're seeing the evolution of APIs overall, and we're starting to see emergence of like gRPC, and we're starting to see GraphQL come into vogue. So when you're thinking about where we've come from, Catherine, what do you think Kubernetes needs next? What is it about Kubernetes right now that it really needs? And Why should customers be thinking about the Cassandra architecture? But that,
Sure.
and why is it better suited compared to other databases out there?
Sure. So I used to lead the technology partner team at DataStax. And when I was thinking through partners that would have a good fit, I would think about partners that were telling the same story. For Kubernetes, that's cloud native. For Cassandra's future, that's cloud native. The same use cases, scale out, distributed applications, the same for both Cassandra and for Kubernetes. The same architecture. Is it really linearly scalable, distributed, hybrid ready technology? And when you start to see more commonalities between the technology, you start to see a lot stronger potential for partnerships. And so when you stand back and you really compare Kubernetes and Cassandra, you've got a technology that's telling the same story, serving the same use cases, serving the same users, and commonly found in the same environments. So ensuring that there's a long-term story for Cassandra and for Kubernetes is really important. And then if you look at version 1 of the New Stack book and the New Stack survey that comes out every year, what you see is that these cloud native developers, the first thing they want after easily built scalable apps is an easily built scalable backend. And now that we can supply that to those users, we have to make sure that they can interact with it in the way that they want. These developers don't want to learn to write CQL. They want GraphQL. They want REST-ready interfaces. They want to write the applications they want to write without thinking about the database. And that's what we have to do next, is make that experience really delightful for them.
That's great. I'm curious then a little bit about then how that relates, Patrick, to the app tier and its development, and how the app tier has changed so much. We've gone from application architectures to almost component architectures in many ways. And those components then are pieced together in microservices. And so when you're thinking about, the app tier, how do you think about the cloud native story then for Cassandra? How do you think about how it fits into this world of microservices, into these components, as we move into like the next abstraction beyond applications themselves?
Well, I mean, of course, microservices is not a new concept. And I think, if anything, Kubernetes has just made it much more obvious and has evolved it into a whole new game. And so if you look at some of the early days of Cassandra, some of the talks that were given around Cassandra, like for instance at Netflix was a very early, strong supporter for Cassandra, but they also talked about how they link together the microservices with the distributed data. So if you think about this domain-driven design of when we build out applications and we build out components inside those applications with domain-driven design, that puts a really interesting, it changes your, not only how you build your infrastructure, but how you build your development teams. You see like, okay, so we have certain groups that are building microservice architectures around a domain problem, and they're sharing those with APIs. And a database like Cassandra really helps along with that because it's distributing the data in a way that is just kind of gets out of your way. If you need to have your data available around the world, this is the database to do it. You can do active infrastructure all day long. It's built to do that. If you need your data out on the edge, this is a database to do that. So we're seeing like some of the most interesting use cases right now, like at Sky UK, where they're combining Kubernetes and Cassandra, how they're building out architectures that are spanning multiple clouds and on-prem. So when you talk about like, well, hybrid cloud, I think a lot of folks think it's a bit of a buzzword, but oh no, there's real companies making real money doing this because they have to. And it's being fueled by this microservice thing that, where we could distribute our APIs anywhere and then persist that data and have stateful data everywhere we go.
Yeah, I'll say that with microservices, we're seeing a lot of times you want to create a stack and say, this is the next this or the next this kind of stack. With microservices, you had this ideal where you didn't need a single source of truth. You would find the fit for purpose solution for each part of the application. And what we're really seeing with our customers, Sky included, is that managing a lot of fit for purpose applications is still a lot of work. Kubernetes makes that so much easier. But as NoSQL evolves and matures, you can have what we often see as a key space per service or tables per service. So the single NoSQL system, Cassandra in this case, really serving a lot of those microservices and providing a simpler architecture with the same value.
So when you're thinking about data and Kubernetes, what do you think is the cloud native story? Because data has historically been treated much differently than the actual infrastructure itself.
Boy, what is the future? I mean, it has to be what has happened with every bit of infrastructure is it has to become less of a thing you have to work through. I talk about where the progress in technologies when we have the ability to be more lazy, and databases are really not that lazy. You have to work hard at making databases work inside infrastructure. So the thing that's exciting for me is when databases become less of a cognitive burden for developers. They're just using data, and they're using data effectively. They're writing entity-based applications using React or Angular or something like that, and not really even thinking a whole lot about like, wow, I wonder if I got that index correct, or this query sure could use a couple more joins or outer joins, or it just makes me sad when I see an application developer trying to extract value out of some business problem, and they spend a week trying to perfect an SQL query, which it's just, or they have a meeting with DBAs like, how can I make my query 10 milliseconds faster? And they start playing around with explain plan. Those days need to be over.
Maybe they need a different job.
Yeah, exactly.
I'm getting this impression from you both. And the impression is the developers just want to get their work done. It's something we hear a lot. And they want to just be able to not even think about the underlying infrastructure itself. But they also want to be able to explore and be able to look at how they can build architectures that allow them to develop really cool stuff. I mean, the acceleration, the use of GPUs has just been tremendous to watch, and how it's changed the way we think about just everyday things, objects and applications we use, and the built-in intelligence into them. So how do you give them that balance then? How do you give them that balance so they can still be able to build these next generation applications, but use the data in a way that allows them to really take things to the next beyond?
This is a really exciting space, and it's really where a lot of our roadmap is focused. In different fields, you see this in storage. You see this with things like scale out SANs coming into play, where you may want to build a high growth application or know that you're going to have an enormous amount of data, but you don't want to plan for that from day one. Or maybe you don't know how popular this application may become, but replatforming it in a year is definitely not something that you want to have to think about. So Cassandra has done a really great job of serving folks that know that they absolutely need scale and high transactional throughputs. But we haven't adequately served developers that want to future-proof for possible growth. So to do that, we need to do things like abstract the developer layers from the database. Things like schema migrations should be able to happen without impacting the developer. So I mean that a developer can write really crappy code if they wanted to. And it can create a really crappy data model. And on the back end, we should be able to migrate and change that data model to something massively scalable without having any impact on the developer. And those are the really interesting things that we're working on and thinking about.
Yeah, it's interesting. If you look at what's happening with the same companies that were doing interesting things when we were trying to scale out applications on the internet, what they're trying to do now is reduce the cognitive burden for their developers around data. That is a high priority. You look at Facebook, you look at Google, you look at Netflix, Apple. All these companies that's one of their singular focuses because they need better developer productivity. But to your point, it doesn't mean that developers are becoming really like they have this boring job. They just get to do new things and not have to worry about the old thing. And it's still an exciting place. It's the fastest growing field on the planet for a reason.
And when you're thinking about this for your community out there, these developers who you want them to not have to think too much about the query, not think too much about the actual, the underlying architecture. What is it that you're looking for in Kubernetes that you want to build upon that allows for that? Stateful sets, for instance, have been talked about for a long time.
Mm-hmm. Cassandra is great at scale, but it still has required a lot of manual intervention for certain tasks. And Kubernetes is this, robotic operator for a lot of Cassandra tasks. Let's say that you want to, we know the types of failures that we see in hardware, and the ability to recover from those failures without any manual intervention, the ability for a system to orchestrate rolling restarts instead of humans, the ability to anticipate load and scale as you need. These are all things that Kubernetes really offloads from Cassandra operators and makes their life a lot easier. And then to Patrick's point, just like with the developers, if you're not focused on the more complicated task, there's so much more interesting stuff that you can do.
Yeah, I use this acronym. I'm borrowing an acronym that's already in place. SRE: scalable, reliable, elastic. And that's cloud native. I think if you ask any developer, do you want to build an application that's not elastic or not scalable or not resilient? I think they would probably say no, or leave me alone. I'm using my Visual Basic. So either one, but those three things, the S, the R, the E, that is what we're trying to drive towards, and getting parity between what Cassandra is very scalable, reliable, maybe not as elastic. I think that's one of the weak points, but that's something that's something we're working hard on changing. Elastic meaning not scale up, scales up great, scaling down. What happens whenever you don't need it? And, building that into a database means that now you have less trade-offs as a developer. I want the S, the R, and the E. Don't give me a lot of, don't make me have to have a whiteboard session with 20 people to sort out what technology I'm going to use. Make it obvious for me. And I think that's where we're coming together. This cloud native data is just obvious.
Obvious. And so maybe, Catherine, you can talk to the obvious. What are some of the things that should be obvious?
You should be able to start with, let's say, 3 nodes. And as your application scales, so should the data backend. You shouldn't have to worry about if a data model that works great for smaller use cases is going to scale or have, wider, larger partitions as the application becomes more popular. You shouldn't have to take a 2-week course in data modeling just to be able to successfully, build an application. You really shouldn't have to think of the complexity of the connections between the code that you're writing and how it scales, and independently think of the data backing it and how it scales. These things should scale and move together, and you should be able to think about them holistically.
When you're when you're thinking about that, and you mentioned the backend, and Patrick, I'm asking you this question specifically about the open sourcing of the backend. And I know that in your recent service that you announced that open sourcing the backend served as a priority. I'm curious why, and how does that suit the developer who is looking for this cognitive leap?
I'm assuming you're talking about the operator here.
Yeah.
Yeah. But there's more to it. But wait, there's more. But right now, the operator is really a key part of this. And, operators in general have done a really good job of bringing, they're like ambassadors for Kubernetes. And they're bringing technology that has been developed outside of the Kubernetes ecosystem and bringing them into the world of Kubernetes in a way that, is a translation. And so if you look at how many operators are out there and what they do, there's just an absolute explosion of them. Go to Operator Hub and you're going to be there for a while. But for Cassandra, what we wanted to do is create that, get closer parity. So when you create your deployment YAML that you're going to put in, or you're building a Helm chart or however you deploy your application, it's all tucked into one place. One of the things we don't want to have is this separation of concerns where, well, we have our Cassandra team over here, and here's the IP address for that. And then here we're going to build our Kubernetes application over here, putting it all in one place. But the operator that we are working on now, and actually also in the project, we're working on a common Cassandra operator in the project, is to make it so that you can do more with less. You don't need a massive team of engineers to run your Cassandra cluster. That you have a lot of the smarts have been built into what needs to happen. The operator is the analogy of a robot. I think it's great. Like it's, it's the Roomba of my data center. Although I don't know if I really like that analogy too much because my Roomba isn't really that super smart. Let's kick it up a notch. But it's thinking about like, okay, I can deploy some really complex distributed applications with a minimum amount of people to do it. And I think that's the promise.
And just for background for people, the DataStax Kubernetes operator for Apache Cassandra, it automates a process of deploying and managing open source Apache Cassandra or DataStax Enterprise in that Kubernetes environment. And we know what Kubernetes is. And so that operator's role is to then take care of a lot of these tasks so those developers can make that cognitive leap. Catherine, is that a fair assessment?
I think it's fair. I think if you take a step back and say, what's the simple reason here that we're doing this? Cassandra needs to meet developers where they are. You shouldn't have to call your ops team to try out a new use case. You shouldn't have to know how to deploy a cluster just to start writing code. This is how developers have told us that they want to interact with the product. It should be easy to install, easy to use, easy to burn and try out new use cases. They should be able to deploy it in AWS the same way they do in Azure, the same way they do on-prem. And the easiest way for us to give them all of those things is just to say, here's your operator.
And when you're thinking about the language that people are familiar with, who are developers, who do not have that background, as you're saying, and would have to take courses to learn, they'd have to be able to go on a pretty steep learning curve. How do you keep the learning curve relatively flat? Does that come in when you start to think about the interfaces themselves for the Cassandra service?
We really start to think about what is table stakes functionality for any database. And as NoSQL matures, make sure that we have an easy answer to all of the table stakes functionality. Things like joins, materialized views, flexible indexes, things that you would expect from a relational and might be surprised the first time you work with NoSQL and things are more difficult than you expect. We are stepping through each one of these and just crushing them to provide just the delightful experience developers want from these, cloud native databases.
So and that comes down to using things that they're familiar with. I would expect then GraphQL and REST
Of course.
APIs.
Sorry, I was a bit of a tangent of an answer with that question. Yes, developers want GraphQL, and they want Go. They want modern languages. They want to take some production schema, upload it, and say, "Give me a REST interface and let me get started." With things like separation of the development layer from the Cassandra backend, we can really accommodate any of these options for developers now.
Now, Patrick, Cassandra is pretty powerful, and it's been around for a long time, as you were saying earlier. What do developers want in 2020 from Cassandra? And what do they want in general that intersects with what they're looking for from Cassandra?
Well, all right. So we actually asked that question, and we got a pretty resounding answer. Cassandra is undisputed as one of the most powerful databases you can use. It's running the biggest workloads on the internet, period. The issue that most developers have had with Cassandra is it's difficult to learn how to use it. You cannot start your journey with Cassandra and expect to have that be productive in a day. And that's just been how it worked. Now, what we can expect from 2020 is, along what Kat was saying, is like we want to reduce the amount of burden on a developer so they can have access to all that power. It is a very powerful distributed database. It gives you tons of options in that regard. It scales like no other database. It will run any workload you can think of and run it really well at low latency. But it doesn't mean anything if I don't know how to use it, or I get stuck or broken. Unfortunately, one of the things, like for instance, data model, you probably will fail on your first data model. Well, we could fix that? We can make that different. Using a driver to connect to the database. Well, maybe I don't want to use a driver. I just want to use an HTTP API. And then when it gets down to just being able to manage like where we're headed with Cassandra, and this is an open source. This isn't just DataStax Enterprise. This is the Apache Cassandra project. Putting more options in front of developers that make it easier for them, like joins, and that you don't have to really worry about it. My ultimate dream for someone using Cassandra in the 2020s is that day zero, they are productive. The first day with your first day with Cassandra is just as productive as any other day. And we're going to make that happen. We have some really focused engineers. The project is really juiced up right now. I think we're going to see this happen. What
about the community? What about the Cassandra operator for, on DataStax is relatively new. Mm-hmm. And the community, I know commits are always slow and starting to come in, and sometimes projects take off in ways you don't expect. Who is the community? Who are the people that you're looking for? What kind of expertise do they have?
I think that we're seeing a resurgence of interest from the community in Cassandra. I think as Cassandra moves to being more cloud native or fully cloud native, we're really being embraced by the Kubernetes community and seeing a lot of interest from different groups. We really stick to our kind of underlying principle that to go far, we must go together. There are enterprises like Orange and others that have also built operators, and we really have to, work together and make sure that we're moving Cassandra forward as a community, which we are one participant of.
It's interesting. I have to say, we have some evidence behind this resurgence. The folks at Sky said something very obvious. It was fun because I like to hear it, which is if you're using data with Kubernetes, because what other database would you use besides Cassandra? And we've been doing workshops on building cloud native applications with Cassandra, and we have over 10,000 people coming to those. That's an enormous load of people, and most of them are new Cassandra users, because it's like, a great restaurant that it used to be a secret. Now it's the word's getting out. And as we're seeing more developers build these cloud native applications and using technology like Kubernetes, they're like, oh, I need a database that can keep up with this. Oh, this has been around the whole time. Welcome to the team. So our community is really juicing up right now. I'm really excited.
How are you diversifying the community? How are you making sure that it is inclusive? I mean, a big part of what makes an application really effective is in actually the work that's done in the development to make sure that the architecture is correct, to make sure that the developer experience is right on. And a lot of that comes down to like having people who are building that technology, building that architecture, who have different viewpoints, have different life perspectives, who come from different backgrounds.
The Cassandra community is not diverse enough right now. And we and every other tech company should just be trying things, accepting that some of the things that we try may not work, might fail. We're encouraging those in the community to really use their voice, share your opinion. We are encouraging contributions that aren't limited to code, evangelism, learning. We have friends in the consulting space that are now managing a Cassandra website, posting jobs, posting blogs, really supporting the community. Internally, we're trying a thing. I think we're going to call it Jumpstart. We're going to offer mentors. The program is specifically for women, people of color, and really any underrepresented group. Learning Cassandra, like Patrick said, can be intimidating. Let us help you. We may not get these things right, but we will start trying a lot of new stuff, and we're just going to keep going. Fix the things we get wrong, and fix this.
Great. When you look at Cassandra on DataStax, and I'm glad you're very upfront about that, Catherine, about the diversity aspect of things and how everyone needs to do better, and I totally agree with that. But when you're thinking about Cassandra on DataStax, and you're thinking about the limitations that it has, what are some of the top 3 limitations that you see? I mean, it really is really new in many ways, the operator model, and in particular,
Sure.
and what is it that it lacks right now? I know that it doesn't support all the cloud services, for example. You need to be using some of the latest releases for DataStax to be able to use the operator. What are those? What are those? What I'm trying to get to is like understanding the constraints that you're facing and how you're working within those constraints to build this service and build this these capabilities that you've been talking about in this show.
Yeah, I really wish that Kubernetes and Cassandra were kind of born at the same time. There are so many things that we've orchestrated within Cassandra that could have easily been orchestrated with Kubernetes. And some of those things like backups within our enterprise product really might fit better as a sidecar or separate process within the cloud native environment. So breaking some of those things out and apart and giving more control to the users, things like that also invite more contributions from the community. There are open source backup solutions, there are open source management APIs, and providing a more pluggable interfaces will invite more contributions. So that's a big one for me, Patrick.
I mentioned it earlier, but I think this is such a big deal. Scale down. It's really a hard thing to do. It's certainly doable with Cassandra, but I think it's not a problem we've solved. And Kubernetes has made this more obvious now than ever. If you do a kubectl and scale down, you've got the operator has to do a lot of extra work to make it work, and it may not work correctly in the first place. There's a lot of gotchas. I think this is a huge area of opportunity where we could do a lot better. Mainly because I think there's a lot of workloads that are ephemeral. You need it for an hour or two, and then you should be able to not have to pay for it just sitting there waiting. largest workloads are like that. I think that's a big one as well.
Yeah. With the operator, each thing that we add into the operator reduces a headache for our human operators. And the things that aren't there for our enterprise product, like support for our advanced workloads, the search, analytics, and graph, those are still the biggest headaches for our real operators. And so those are the harder things to orchestrate, and those are the harder things to manage in production systems. And so those are the things that we're working through and adding into the operator pretty quickly.
I think another one too, which is, I think every database's challenge is storage options, and how many different options we do have. Right now, you have very little, but that's one of the, I think a really interesting priority of the project is building in these pluggable storage architectures. So we can use a variety, because if you deploy into a cloud environment on-prem, but we have options, and we have, it's compute and storage. What if you could have infinite compute and storage? Well, we're really good at consuming the compute. What about the storage? And Kat mentioned really interesting advancements in storage right now in the cloud native space with like distributed SANs and things like that. But also like the type of storage engine for your data and giving you more options there. Facebook is really, Instagram is one of the famous Cassandra users, but they use RocksDB as a storage engine. And they call it Roxandra. Well, why? Because it's really good for the type of data that Instagram needs to store, and it's optimized better. So, they went down that path because they have the engineering know-how. We're trying to pull that into the project now and make that a part of, when you're deploying it on Kubernetes, you should be able to define not only the middle layer, like how you want to access your data through GraphQL, some other HTTP API through Ingress, but also the storage option underneath. How do I want to store my data?
So let's conclude by talking about the approach you've taken with operators and how you expect the approach to evolve and what that reflects on data stacks and Cassandra and Kubernetes in particular.
Sure, I'll take it and then throw it to Patrick to close. With Astra, that's our cloud native Cassandra service. We really want folks to have the same experience using an as a service that they can eventually have with their on-prem options. To offer, if you're a bank managing Cassandra applications throughout the organization, you should be able to very easily offer your Cassandra consumers internally SLAs and very specific expectations. And so everything that we're building into the operator, we're really thinking through how to provide a ubiquitous experience in Astra, our cloud, on-prem deployments, and self-managed cloud deployments as well.
Yeah, and in addition to that, I would say that we also want to see this place where developers are working with a database or with our database and Cassandra or DataStax Enterprise, and it can start on their laptop and end in the largest cloud or in their own data center with almost no changes to their application as they go along. And an operator and making the correct changes, it should all live in one spot. So if I'm doing a simple deployment using Minikube on my laptop, and then I deploy it in EKS or in GKS, then everything should work just fine. I don't have to go back and re-architect anything. And that's one of the really strong, I think one of the things we're driving towards, it has a strong promise for developers. Like, yes, I don't have to re-architect anything. Thank you.
We'll end on that note. No re-architecting. I like that. Probably a lot of people are like smiling right now as they're hearing that as well.
Technical debt is terrible.
Yeah, we all have it, and so we all can relate. Thank you both so much for joining us today. Catherine Erickson, part of the strategy and self-service team at DataStax. Catherine, thanks for joining us.
Thank you.
And Patrick McFadden, Chief Evangelist for Apache Cassandra and Vice President of Developer Relations. Patrick, we really enjoyed the conversation.
Thanks again, Alex, for having us.
Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.
DataStax is the company behind the massively scalable, highly available, cloud-native NoSQL data platform built on Apache Cassandra. DataStax gives users and enterprises the freedom to run data in any cloud at global scale with zero downtime and zero lock-in.